Okay, so the only thing that we lack on 5.2 is I want to talk about graphing. Okay, there are like 3 problems on the bottom of that worksheet that are graphing problems. So why don't we just look at one of them, and we'll talk about it, and I'll show you what I expect out of you as far as graphing is concerned. Now, should you miss any graphing problems? Because what do you have? Okay, people, come on. But there are some things that I'm going to require from you. So, let's see. Of course, I don't have a worksheet. Yeah, if you don't mind. I don't remember what number it is. I know the problem. Oh, no, it's the other one. It's the other worksheet.
The one with the ending?
The one you just turned in. Oh, yeah, you did that last time. It's number 36.
27 to 34.
Yeah. If you had told me that, Luke, I could have figured it out. All right, so this is number 32, okay? And then it gives you a little graph down here, and they want you to graph it. Okay, so I'm going to tell you, every time you're asked to graph something, what do I want you to draw or to write?
The Y.
You can't do that because this is a 4th degree polynomial. What's gonna support my graph? Yep, a T-chart. A T-chart is going to support my graph, okay? So let's just see. Y'all look. We're not even going to pick up a calculator right now, okay? Let's just look at this, and let's just talk about it for a second. First of all, is it even or odd? What is it, guys? Why do you say it's even? Yeah, the highest exponent is a 4. It's obviously a 4th degree polynomial, which you would call a quartic, not quartic, okay? Quartic, a quartic. What's the leading coefficient? -2. So the leading coefficient is what? Positive or negative? Negative. What does that tell you? What does even tell you about the polynomial? That's exactly right. He starts and ends in the same direction. He's even, guys. His leading coefficient is negative, so which way is that? That's right. Y'all, this is what my little notes to myself say. Hey, this guy comes from the bottom, goes to the bottom. Okay?
Is that why it's just like a linear number because it's x to the first half?
Yep. Because it's an oh no, I saw that. Because it's an odd one, he begins and ends in different directions. And think about it like this, Abby. If its slope is positive, it ends up going up. It starts from down here. If the slope is negative, he ends up going down. He starts from up there. Okay? See, it's all following the same rules. It's not like they just apply to anything quadratic and above. Okay? It's always. All right. So he begins and ends down here at the bottom. Now, what's this x to the 4th going to look like? Huh?
3. 1, 2, 3. Yeah, 4 directions.
Okay. He could have at most how many humps? 3. It's always one less hump than there are, okay? He could. Now, y'all look. If you didn't know that, could you punch stuff in your calculator and your calculator show you that? Okay? But y'all listen, you're not paying attention. How many humps does he have? This guy right here.
It looks like 1.
Yeah. Why? Why does he, if he could have 3? Yeah, y'all, he doesn't have any stuff in there. He doesn't have any x to the 3rds or x to the 2nds or anything like that. What is he going to look like? A parabola. That's exactly right. He's going to look like a parabola. Okay? This 4th degree just might make him a little bit flatter across the top, in this case, because it opens down, all right, than a quadratic would. What is this 2 going to do to that? Yeah, he's going to make him narrower. Now, is it going to make his bottom narrower? No, it's just going to, after he does that little flat piece there, it's not really flat. It just looks that way, okay? Then it's gonna go down really quickly, very fast. All right. What's this negative doing? Yeah, he's opening down. That just justifies what we were saying. He's even, so he begins and ends in the same direction. His leading coefficient's negative, so it's down. What's this 1/2 do? It's what? That's his y-intercept. Y'all, he just moves him up 1/2. So he's going to start right here. Okay? Now, what am I going to do now? I'm going to plug it in my calculator. Okay? I'm going to go to y equals, there it is, negative 2x raised to the 4th plus 1/2 output 0.5. Same thing. Okay? Look, does it look like what we thought it was going to look like? Hello? Thank you. Now, what do I want to look at? Now, I want to look at my table. So I go second in table and look. Oh, my word. Do I have a heart attack? No. What do I know? Somebody put my calculator in scientific notation. So it's not a big deal, people. I just go back and go, ooh, I'd rather you be in normal decimal notation. All right? So now I'm happy. Here it is. Now, guys, look. Am I going to put negative 4 in my T-chart? Not unless you want to plot negative 511.5. Okay? Look how fast. Look, people, you can't put a whole bunch of numbers in your T-chart. I mean, even after negative 1, look at negative 2, negative 31.5. Okay? So I'm just going to put these 3 numbers right here in my T-chart. Negative 1, 0, and 1. There's my answers right there. So, negative 1, it's negative 1.5. 0, it's 1/2, or 0.5. And at 1, it's negative 1.5. And then I'm going to plot those points because my T-chart should support what? My picture, my graph. So there's my 0, 1/2. Here's my negative 1, negative 1.5. My positive 1, negative 1.5. And there's my answer. Okay, so did you miss any of these? Y'all, you got a calculator. If you miss any of these, shame on you. Okay? All right, everybody okay? Okay, so that's the end of 5.2. Let's talk about 5.3. 5.3, we kind of talked about it the other day. It's on adding, subtracting, and multiplying polynomials. Okay. Adding. How do you add polynomials? That's right. You're collecting like terms, people. Is that hard? No, you did it in Algebra 1. You did it in geometry. Okay? I'm hoping you can do it here. Let's talk about subtracting. I'm going to give you an example of subtracting. Okay? This is example 2 in our book. Here's what it says. There's just one thing that I want to address. Well, really 2 things. Subtract 3x to the 3rd plus 2x squared minus x plus 7 from 8x to the 3rd minus x squared minus 5x plus 1. Okay, so here's the first thing I want to address. Who goes first? Yeah. If you're going to take this one from this one, then this guy has to go first, okay? You can't take that from him if he's not standing up there first. So, 8x to the 3rd minus x squared minus 5x plus 1 minus. Now, can I just write this polynomial here?
No, you have to change all
You have to put parentheses around it. Now, the parentheses are going to do what some of y'all said, which is, what does the minus sign outside parentheses mean? Change all the signs. So that's what's going to make you. Y'all, if you don't put the parentheses there, then you're not going to subtract everything. You're only subtracting the first term. Okay? So a minus sign outside parentheses means change all the signs. So 8x to the third minus x squared minus 5x plus 1. The opposite of, pardon me, a positive 3x to the third is negative 3x to the third. The opposite of a positive 2x squared is a negative 2x squared. Opposite of a negative x, good. And the opposite of a positive 7, awesome. Okay, so now we're going to collect our like terms, right? Who do I start with? Yeah, your highest power, because it's proper to write it in proper standard form. So, you're going to collect your like terms. What's 8? This is what I like to do. I like to cross them out because then I know I've used it, okay, or I accidentally left him out, or whatever the problem may be. What's 8x to the third minus 3x to the third? Perfect. What's a negative x squared and a negative 2x squared? Awesome. What's a negative 5x and a positive 1x? Okay. And then, what's a positive 1 and a negative 7? Very good. Okay? Is that hard? All right. So can everybody add and subtract? I mean, the only thing that would be different if this was an addition sign, you could just drop the parentheses. He doesn't change anybody's signs. Okay? So you could just drop the parentheses and keep everybody collect your like term. Okay? All right, so let's talk about multiplying. This is example 3. Example 3 looks like this. I'm going to multiply negative 2y squared plus 3y minus 6, and I'm going to multiply them by y minus 2. Okay, so really, guys, this is like a free-for-all. The only rule is everybody gets multiplied by everybody, okay? That's all it is. So, to keep you from making careless mistakes, I like to teach you an orderly fashion, an orderly way to do that, all right? It's normal to take the smaller. Now, if they're both the same size, does it matter which one you separate? No, it doesn't matter, okay? But if they're not the same size, we usually take the smaller one and we separate him out. So the first thing we're going to do is we're going to multiply y times all of this. So I'm going to write that. Y times negative 2y to the second plus 3y minus 6. And then I'm going to take 2 and his sign. I don't care if it's negative or positive. You have to write the sign down, okay? And we're going to multiply him by all that. So negative 2y to the second plus 3y minus 6. And now it's just distributing, okay? I'm going to show you one little trick that you can do when you distribute it. First of all, we're just going to distribute the y, and we'll get negative 2y to the third. Because when you multiply, you're adding your exponents, right? And then y times 3y makes 3y squared. And then y times negative 6 makes... Okay, so here's where I'm going to do something different. First of all, I want to bring this to your attention. Remember when you learned the distributive property, one of the things that gets a lot of people is if I distribute a negative, they'll mess some signs up. So you need to be really careful. If you see that negative that you're pulling through, think to yourself, hey, I got to change everybody's signs. Don't forget that, okay? All right. Remember in kindergarten and first grade when you first learned how to add and subtract and y'all did it vertically, up and down, because that was the easiest way? You could do this vertically if you wanted to. When I'm writing these terms down, I could write them underneath anybody that he's a like term with, okay? I showed you, here's a way where you don't have to do it vertically, okay? I use crossing out when I do that because you have a lot of things running across your page, all right? So some kids like to do it vertically. So what's negative 2 times negative 2y squared? Positive 4y squared. So I'm going to put him under the y squared because that's what he is. Okay? What's negative 2 times 3y? Negative 6y. So I'll put him under the y. What's negative 2 times negative 6? So he doesn't have anybody to go under, so he goes out there. And then you can just add negative 2y to the third. Doesn't have anybody to collect with, so I'll write him down. What's 3y squared plus 4y squared? 7y squared. What's negative 6y and negative 6y? Perfect. And then plus 12. So that's just another way to do it. This is called vertically. The other one's horizontally, of course. All right? And it doesn't matter to me. I don't care how you do it. Just as long, I just want you to do it right. Okay? That's all I really care about. Okay, anybody got a question? Okay, so what if I had something like this?
We should multiply, we would multiply 2 by x multiple, and then FOIL the first two sets numbers, and then do the
Oh, pardon me. Okay, so y'all, you have 4 things that are multiplied together, right? What if I said, what's 2 times 4 times 3? How many people shout out 24 because they did it all at one time? We don't do that, do they? People either say 2 times 4 is 8, and 8 times 3 is 24. Somebody else might go, oh, 2 times 3 is 6, and 6 times 4 is 24. Or could you go 4 times 3 is 12, and 12 times 2 is 24. So the order that I multiply doesn't affect my answer, does it? Because multiplication is commutative, okay? So I'm going to use that commutative property, and I'm going to make this problem as easy as I can. Now listen to me. If you did it the way that Spencer said, where you multiply this by the 2 by this, and then you multiply these 2, and then you multiply that times this, would you get the same answer as what I'm going to do in a different order? Okay, so I'm going to choose to multiply these 2 guys together first. Does anybody know why?
Because it's
What are they? Thank you. They are conjugates. Okay? And when you multiply conjugates, what happens to the inners and the outers or the middle term? Yeah, it cancels out. It doesn't have one. So remember, it becomes the difference of 2 perfect squares. So it becomes square the first minus square the last. Oh, well, that wasn't so bad, was it? Okay? Now, y'all, this is going to be the last thing that I do. Because he's just going to be easy just to rip through there and multiply 2 by everything. I mean, why am I going to make it bigger when I could do it at the end and it won't be so bad? Okay, so the next thing I'm going to do these. Now, this is just the full method, isn't it? Because it's just a binomial times a binomial. All right, so it's 2 times what's first times first? 2x cubed. What's the outers? Minus what? 8x. What's the inners? Plus 3x squared. Ooh, can I collect those? No. So who goes next? Very good. And then minus 8x. And then your last times your last. What's 3 times negative 4? Now, can I bust out and multiply that 2 by everything? You see how easy that is? Now, is it wrong to do it the other way? No, people, it's not wrong. Okay? I'm just going to try and make it as easy as I can on myself. All right? So multiply everything by 2 and tell me what you get. Uh-huh. Perfect. And there's my answer. Okay? So, anybody got a question? Plus 6x squared right here? I said there's my 4x cubed, there's my 6x squared. There's my negative 16x, and there's my negative 24. Okay? All right, anybody got a question?
the rest of the
Nikki, are you okay? Did you find? Look up here. Look up here. 2x times x is 2x to the third, right? Your outers give you a negative 8x, and the inners give you a positive 3x squared. You can't collect those, okay? Because they're not like terms. One's an x squared and one's an x. Most of the time you can collect those, but notice that those first two terms are not the same, so that's going to make them different. Okay? All right, everybody okay? All right. Look, I want to show you something. What if I multiplied x plus y times x plus y?
I was going to say x plus xy plus xy.
Plus y squared. Okay? Pretty cool, right? Pretty cool. All right? What if I asked you to multiply x plus y times 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 x plus y?
X to the 6, and then you just put plus
12,
Yeah, y'all listen to me. I mean, could you multiply these two together, and these two together? And then you'd have to multiply this x squared plus 2xy plus y squared times this x squared plus 2xy plus y squared and get your answer there. And then you have to multiply that times this x squared plus 2xy plus y squared. Would it take you a while?
Yeah.
What if I could show you a shortcut?
Well, doesn't that just be the top one's x
You
plus
can't.
y squared too?
Huh?
Isn't the top one x plus y squared too?
Yeah, it is.
how do you get the 2x in the middle?
Remember how your teacher taught you? Square the first, keep the sign, twice their product, right? Plus square the last. Okay, so I'm going to show you how to do something like this. Will it work on this one right here?
Probably not.
Sure it will. Will it work on this one?
If you're me, you know.
Come on, Pen. I don't have time to mess with you right now. Oh. Okay, so.
Is your vertigo problem solved?
Yep.
Cool.
Oh, help me. Okay? Like, who wants to work a problem like that? So, I'm going to show you a really short way to do it. Okay? So, way back a long time ago, there was this guy named Pascal. Pretty cool. He discovered
Was he
what?
a chameleon in a movie?
No. Oh. No, he wasn't, but I'm sure that's where that one came from. Oh, dadgummit. Just a minute. Let me go fix. I know my pencil.
Did he change color? No, I was saying I got sick and tired because my sister watched it one time at 12 days consecutively. I'm not. Yeah. No, I get my things confused.
Okay. So, now what are we fixing to talk about?
And the extra morning.
What are we fixing to... who are we fixing to talk about? Pascal. Okay?
Does he get here?
Pascal. And he was a mathematician, okay? And he discovered what we now call Pascal's triangle.
I don't like triangles.
Nothing like the Bermuda Triangle,
They're so
okay?
naughty.
Now, here's the deal, guys. You have to be able to make Pascal's triangle. All right? You have to be able to make Pascal's triangle. So, some of you will catch on a lot faster than others. All right? So, I'm going to start making Pascal's triangle, and then you try to... Are you okay? Yeah? Yeah.
Especially
Yeah.
February.
So, So some of you'll catch on. When you catch on, you just keep making your own, okay, and give everybody a chance, because there's nothing more irritating than for you to be the first one to catch on and start blurting this out before my brain had a chance to process it. Okay, so here we go. I'll tell you this. Pascal's triangle is always outlined in one. Okay?
Was this in 6th grade?
Yeah, we have that. Oh.
There's no way you've done this. Unless you want to keep it. Cool. A lot of numbers. I can't write that fast. I get it.
I get it. I get it.
Did you call that? I don't think you did.
Can I take a guess on why I've got it?
I don't
Can I
think
take
you
a
got
guess
it.
on why I've got it?
Okay, wait. Let's let everybody look at it for a second, okay? Is it outlined in ones like I told you it would be?
Kind of.
Okay. Now, could I keep going on forever and ever?
You're the one
Okay.
Yes. That's why I have to get number one.
All right. So, Spencer, tell us where we're getting all these numbers.
Okay, can I walk up to that?
Sure you can.
So, you start off with, there's nothing but one. It starts off with one. So you start off with no time with one. 1 plus 1 is 2. 1 plus 2 is 3.
Okay, hang on just a sec. Here's what he's saying.
That's wrong.
Right? What else?
3 plus 3, it's the two numbers above it. So, in this case, 2 and 1 is also 3. And then when you get the 1, 4 will be 5. 4, 6, 10. Then you get down to, okay, what is it? 1, 5.
Everybody got it? Thank you, Spencer. Very good.
You're writing quicker than I can talk.
Yeah.
I know.
I just had to make 2 lines. Okay, so everybody see how to get them? All right. So why is Pascal's triangle so important? What is so awesome about it? Okay, this number right here, this second number,
Oh, this is a binary search tree almost.
this second number tells you what degree, okay, what power you're going to raise it to. Y'all, this is a second power, okay? This is a third power. This is a fourth power. Do you see what I'm saying? Everybody understand that?
Mm-hmm.
Now, what about all those numbers? Y'all, these are the coefficients,
Mm-hmm.
okay? These are the coefficients. Look at a quadratic, okay? A quadratic has how many terms? 1, 2, 3 terms. What's the coefficient of the first term? 1. What's the coefficient of the second term? 2. What's the coefficient of the last one? You see? Watch. What if I said a plus b quantity squared? Okay? Then it's 1a to the second. Keep the sign. Plus 2. Now watch what's going to happen. This guy right here, he's going to start at the highest exponent, and then what's he going to do? He's going to go down, all right? So this is a to the second. What's this going to be? A to the first, right? Look at this guy. Guess what he's doing? He's starting at the lowest, which is 0, and he's going to go up. So he's b to the 0. What's he going to be? B to the first. And then plus, there's my coefficient again, 1, A, 2, 1, no A's, B's, 0, 1, and what? 2. Okay, watch this. This one will. Let's do a fifth. You want to do a fifth? How How many terms will an A plus B to the 5th have? 6. 1, 2, 3, 4, 5, 6. Okay? He's always going to have one more than there are powers, okay? So, let's see. What's the coefficient of the first term? 1. There it is, people. They're all staring at you right across there. 1. Those are the coefficients of the term. Okay? So 1. A to the what? 5th. The highest power that you can have. 5. Plus, what's my second coefficient? 5. A to the what? 4th. B to the first. Because the first term didn't have any b's. He started at b to the 0. Now I'm b to the first. Okay? Plus, what's my next coefficient? 10. How many a's will I have? 3. How many b's will I have? 2. Oh, one's going down while the other comes up. Okay? Look, a's. 5, 4, 3. Look at your b's. 0. There's not any b's. 1, 2. What's this one going to be on the b? B to the 3rd. Okay, what's my next coefficient? 10. A to the what? B to the plus. What's my next coefficient? A to the B to the plus. What's my last coefficient?
1.
No A's, people. You ran out of them. 1 and then 0. B to the 5th. Okay, so take a second and look at it. Okay? That's pretty cool. Is that not a whole lot easier than multiplying A plus B times A plus B times A plus B times A plus B times A plus B?
I know, it took a long time to draw the triangle.
Oh my word, it did not. Alright, so here's what I want everybody to look up here at the board, okay? Here's what I want you to understand. 1, 5, 10, 10, 5, 1. Here they are. Look up here. 1, 5, 10, 10, 5, 1. That's the numbers in front, okay? Here's the first letter, A. He starts at the highest exponent, 5, and he goes down by 1. People, can you count down from 5 by 1? Then you can do this. This is not hard. A to the 5, 4, 3, 2, 1, 0. Okay? B. They start at the lowest number, which is 0, and they go up by 1s until you get to 5. B to the 0, 1, 2, 3, 4, 5.
Quick question. What would happen if A plus B plus C?
You can't use Pascal triangle. All right, so here we go.
Pascal.
Okay. The first variable is always going to go down and the second one's always going to go up.
Yes, yes, very good. All right, so everybody ready? Here we go. I want you to do this. I want you to do x plus y to the 6th power. X plus y to the 6th power. Go. All right. Everybody got it? Everybody agree? These are my coefficients? Okay. All right, so let's go. What are you starting out with? 1 x to the 6 plus, what's my next one?
6x to the 5th, y to the 1st.
Now, I don't have to write those ones there. Hey, anybody notice anything about all these little terms? That's exactly right. Y'all look, this is a 5. That's a 5. What's 4 and 1 make? What do 3 and 2 make? 2 and 3. 1 and 4. Oh, it's just a little check. Okay, it's just a little check. All right, so what's the next one?
15x to the 4th, y to the 2nd.
And I'm still at 6, right? Plus, what's the next one?
20x to y.
That thing
Still
that,
making 6.
that thing that we did with the, like 1x is 3 and then you do the opposite of the house, that wouldn't work for this way.
Synthetic division?
Yeah, no.
I don't know what you would use it for.
Me.
Okay, what's the next one?
15x squared, y to the 4th.
What's the next one?
6x and y to the 5th.
What's the next one?
1y to the 6th.
Nope. Nope. All right. Anybody got a question? Ask me now, because I'm fixing to make it more difficult.
Please don't throw a fraction. Please don't throw a fraction.
Okay. I'm not going to throw a fraction in there. I just want to, show you, let's see. I need to move you out of the way. I still want to see my little chart. Okay. How can I make it more difficult? What can I do to this to make it more difficult? Well, instead of just having X's and Y's or A's and B's, I could put numbers in there. I could put numbers in there. Okay? So let me show you what your numbers are going to look like. What if I had 2x, and instead of a plus sign, what if I put a minus sign? 2x minus y. And I raised it to the, let's raise that one to the 5th power. Okay? Now this one, we're not going to do it in one step. It's going to take us 2 steps. Okay? So first of all, I'm just going to tell you that all this minus sign is going to do is, he just means that I'm going to alternate signs. You're always going to start with a positive, okay? And then it's just going to go plus, minus, plus, minus, plus, minus, plus, minus. That's all a minus sign does. So that's not really a big deal, is it? Okay. So, now here's what is a big deal. Here's the 5th one right here, guys. There's the numbers I'm looking at. Okay? So first of all, I have 1 times. Now, what do I have to raise to the 5th power? 2 and x. You see what's happening? So now I'll have 2 to the 5th, x to the 5th. How many y's will I have? None. It'll be more beneficial to write it like this, and I'll show you why in a minute. Okay? All right. What sign goes here? Minus. Yeah, because this one's a plus. The first one's always a plus. It always goes plus, minus, plus, minus. Okay? So, always a plus, and the second, you're alternating. It's all you're doing, guys. Okay? Now, what's the next coefficient? 5. Times. How many 2x's do I have? 4. So it's 2 to the 4th times x to the 4th. Any y's?
1.
And I don't have to think about this negative sign anymore, do I? Because I'm doing what? I'm alternating my signs, so then I don't think about it. Okay? So, what's the next sign? What's the next coefficient? You see what it's done? It's taken one more thing into consideration. All right? And that is that 2 right there. How many 2's do I need? 2 to the 3rd, x to the 3rd. How many y's do I need? Now look, are my variables still adding up to be that 5 right there? Yeah, they are. 3 and 2 is 5, 4 and 1 is 5, 5 and nothing's 5. Okay? This right here, we're going to go back and that's just a number, guys. Okay? We're going to go back and do that number. All right, what's my sign? Minus. And my coefficient is 10. Okay? Times. How many 2's? And how many x's? And how many y's? Okay? All right, what's my sign? What's my coefficient? How many x's? No, how many 2's? Sorry. 1. How many x's? And how many y's? What's my sign? What's my coefficient? How many 2's? How many x's? How many y's? Okay, so now, watch what we're going to have to do, because guys, listen to me. This is not an acceptable answer, okay? We just need to simplify it. That's all we're going to do. What's 2 to the 5th? 32. I told you you needed to know that, okay? What is 32 times 1? So that's 32 x to the 5th. All right, you see where we're going now. You ought to be moving on along. What's 2 to the 4th? That's square it and square it. That's 16. What's 16 times 5? So negative 80, x to the 4th, y to the 1st. Plus, what's 2 to the 3rd? What's 8 times 10? X to the 3rd, y to the 2nd. Are y'all with me? Now, what's going to make it even harder? If I put a number in front of the y and the x. You see what I'm saying? Because then not only do you have this y to the 1st, you'll have another number right there. You'll have to collect all those numbers and multiply them together. You got a calculator, people. Okay? Don't go crazy and wig out on me. What's 2 squared? 4. What's 4 times 10? So negative 40 x squared y to the 3rd. Woo, look here. What's 5 times 2? So 10x y to the 4th minus y to the 5th. Okay, now is that hard? It's not really hard. There's a lot of room to mess up. There is a lot of room. It's very methodical. Okay, now I'm going to tell you this. Are you going to be successful on this on the test if you don't practice it? People, you're not. I mean, I'm just here to tell you, you will not be successful. Okay? So, I'm going to give you 3 problems. So, here you go. Here's your first one. I'm going to start off easy, get a little more difficult, and then a little more difficult. So,
You would only have to go up to the 6th
now listen to me. Am I going to give you Pascal's triangle on the test? No, people, I'm not. I'm not giving you Pascal's triangle on the test. Okay? So, you have to know how to make Pascal's triangle. Here's the first one. Here's the second one. Yeah, I will. I'll probably put 2 on there. They take a little bit of time, okay? They do take a little bit of time, but they're not really hard. So you write those down, and then I forgot to tell you one thing. I want to go back and show you one thing, okay? It's not, it's just, it might be something that'll help some of you, okay? All right, everybody got these written down? Okay, so here's what I want to do. I want to go back for just a second because in the other classes we talked about this problem right here. What if I wanted to check this problem and see if this answer was correct? Be too hard to factor that. Plug in what? Oh, there you go. Jada said, hey, what if you picked a number for y and you plugged it in this equation? And I'm just going to tell you that I normally don't choose ones, but that's only because I know ones sometimes special things happen because it is a 1, and so it could cover up your mistake. Okay? I normally choose something like 2 or something like that. Okay? But, I mean, you're just plugging it in, so it's not a big deal. Y'all plug it in just like this. I'd open parentheses, -2, open parentheses, 2 squared. You don't even have to put 2 in the parentheses because it's not negative. Plus 3 times 2 minus 6, close the parentheses, open them, 2 minus 2, close. I probably wouldn't choose 2 minus 2, 2. Because he's going to make a 0, and then it's going to be hard to check. But you still could do it, okay? And then you're going to plug that same number in right down here. And what should these numbers be? Yeah, y'all, if they're not the same, you're wrong, okay? If they're not the same, you're wrong. So that's just a little way that you can check those kind of problems because there's not really any way to. You don't have a way right now to factor that bottom one. That would be a good way if you could factor it, but you can't right now. Okay? All right, so I'm through. Yeah. So y'all get to work on your little problems. All right? And if you need some help, I'll help you.
Wait, yeah,